So in this section, we're going to be rationalizing denominators. In 8b, we simplified radicals that had fractions. And to do that, what we did was to reduce the fraction if it was possible. Then we would follow up and simplify the radicals that were in the numerator or the denominator if possible. For example, here is a problem. I want you to try to remember these two steps. So stop the video. All right, so now if a fraction has a radical in the denominator after you've done those two steps, so after it's been reduced and simplified, the denominator must be rationalized. So that means to change it. That means to eliminate the radical in the denominator. So it also, what it means is to change that radical, which is irrational, into a rational number, like a whole number. To rationalize a denominator that has a square root, you're going to multiply by a clever one by multiplying by both the numerator and denominator. By the radical that is in the denominator. So for example, here we have the square root of 3/2, and we see that it doesn't reduce, and I don't know the square root of 3, and I don't know the square root of 2. So then I want to make this into a perfect square so I can take the square root of it. So I want to multiply it by a 2, so I'm going to make a big square root there. And I want to get the square root of 4 down there. So whatever I did here, I need to do the same thing in the numerator. So 2 over 2 is 1, and 1 times anything changes the looks, perhaps, but not the value. So then when I multiply it, I'm going to get the square root of 3 times 2 is 6 over 4. And we know the square root of 4. We'll think of them separately. And the square root of 4 is 2, and we don't know the square root of 6. So now I have a fraction that's equivalent to the first one that does not have a radical in the denominator. It is just in the numerator. So B, same thing. I need to then, I see I could actually simplify the top of that. So the square root of 4 is 2, so I'm going to make it a high 2 there. So that's 2, and then in the denominator I still have the square root of 3y. So the square root of 4 is 2. Now I'm ready to rationalize it, so I want to multiply by that denominator over itself like this. So when I multiply a radical times a radical, it's going to make it a square, and I can bring it out. So square root of 3y times the square root of 3y is going to simplify to 3y, no radical. And in the numerator, I have an outside and an inside, so that's going to be 2 square root of 3y. So you've got to pay attention to if it's inside or outside the radical, and then think about what you're multiplying here. The kind of the in-between steps here would be that it looks like the square root of 3y squared. Anytime you take the square root of a square, you come back up to that. All right, so you try C and D. Let me stop the video. Okay, so now we're going to rationalize a denominator that has a radical that is a cube root or larger. To do this, you must multiply both the numerator and the denominator by the radical that makes the denominator a perfect nth power. So I'm going to write right here perfect third powers. So this is kind of for example. 2 to the third, which is 8, 3 to the third, which is 27, 4 to the third, 64, 5 to the third, 125, kind of etc. And then for variables, we'd have to have an exponent of 3. So x to the third, y to the third, any combination with a 3 there, you could also have like an a to the 6. So some exponent that my 3 will go into evenly. So these are perfect third powers, and I want to change my denominator into that. So here on example 2 where it says rationalize this denominator, I see the cube root of 2, so I see it's a cube root. So I know I can't do it like I did the ones above. I need to do this. So I need to think a perfect third power for 2. 2 to the third would be 8. So I want to change this into an 8, and to do so, I would need to multiply by 4. Okay, does that make sense? I want 2 times 4 to give me this 8 right there. That's perfect. And I need to do the clever one, so I need to have exactly the same thing in the numerator. All right, so now when I multiply, I get the cube root of 8 here. And in the numerator, I have the cube root of 4. I don't know the cube root of 4, so that stays. And in the denominator, the cube root of 8 is 2, and that's my answer. All right, I'm going to stop there, and I'll pick up on the next video.